didn't become addicted to alcohol, but in some way I become addicted to Twitter, and I'm trying to fight this right now. But anyway, there is one certain tweet that I would like to share with you that is very important for me, and it says that there are certain steps in learning programming skill. The first step is, can I do this? If I am about to solve a problem, am I able to solve it anyhow? Even if there is a crappy code, can I do it in just any way? The next step is, can I do it more easily? Then maybe I can reduce the boilerplate, maybe I can reduce the overhead, remove repetition, and reduce 10 lines of code into 3 or 4 lines of code. The next step is, maybe I can replace object-oriented programming with functional programming, because this is what the cool kids are doing all around the place. And I believe most of us has reached this step or are about to reach this step, but there is one more. Can I not do this at all? And the last step takes a lot more experience and a lot more time and effort to actually find out that something that we are about to do might not be needed at all. You ain't gonna need it, bro. And think about all the situations where you did have a working solution and you thought, maybe it's not that generic, maybe I could make it support more use cases, and you spend a day or two and you actually have managed to support the use cases. But eventually they never happened. And maybe you've had some thoughts about this later on or not. But this is what I would like to concentrate on. I would like to think about how you could think about alternative ways in order not to do something, or basically keep the simpler working solution in regarding to architecture. This talk is called The Future of JavaScript Architecture. My name is Tomasz, and I'm running my own consulting company. I help teams better understand the software they create. I help them scale it and deliver it faster. I also do trainings on JavaScript-related technologies. If you need my help, then please feel free to contact me. Now, there are two important things in regards to front-end architecture. Each framework has to answer two questions. The first one is, how does a framework know which part of the UI to update? Certainly, we don't want to update the whole page, but only the pieces that change. The second question is, when should we do it? An example answer to the first question is Virtual DOM. One of the libraries that implemented is React. Now let's take a look at the idea of the reactive algorithm. You have to know, some of you are probably aware of that the most expensive operation in frontend is actually DOM manipulations, because if we change any part of the markup, then it might be followed by a repaint that will take a lot of calculations and a lot of time. So we're trying to do as little manipulations on the DOM as possible, and to spend as little time doing it as possible. And the idea that React has implemented goes as follows. So what we have highlighted here is the tree of our components. Basing on the components, React is producing so-called virtual DOM. So we're not touching the DOM at all. We have a virtual implementation, so basically a tree of lots of plain JavaScript objects. If there is a change, something has changed in our application, a second tree is created. And now React is basically traversing the trees, finding what are the differences, and basing on the differences is creating a sequence of very atomic changes, of very small, very precise changes on what should be applied to DOM. Now, at this point, nothing has been touched. DOM hasn't been touched at all. So it's not blocking the UI. Finally, when the sequence is calculated, it's basically applied to the DOM. Now, thanks to this approach, the developer can write code that is basically agnostic on which part should be re-rendered. We just define what the component is. Virtual DOM works very, very fast, and React has yet introduced lots of optimizations on, let's say, skipping a part of the tree, not to get re-rendered, like pure components or React.memo. But the thing is, can we do even better than this? Now, let me introduce a new framework called Svelte. Well, actually, it's not new. It's actually already 4 years ago, 4 years old. But let's just go through how this looks like so that we're on the same page. This is just a convention of what the author has decided. The component is split into the script part, the logic, and the markup, and if you add also a CSS part. So basically, this is how we split the concerns, just like in HTML. Our component is stateful. There is one single variable, price, that holds a number. There is a function, handle click. Basically, when we invoke that function, price is going to be incremented. And in our markup, this syntax will make the button label update whenever the price changes. And finally, our callback is bound to the button. Whenever button is clicked, the function gets invoked. So this is just syntax of Svelte so that we can carry on with the other examples. Now, if we want to challenge status quo, and there is already an implementation, some engine that is very, very good and very performant, it might not be very easy to introduce something even better and even faster. Sometimes it's smarter to think about a completely different approach. And so, welcome to Incremental DOM. The idea behind Incremental DOM is that we are not trying to create any kind of virtual implementation, because if we do the virtual implementation, we have to do it in runtime. So basically, whenever our application changes, we have to recalculate the trees in runtime. And what Svelte is doing is moving some of the runtime stuff into the compile stuff, so that we create the compiled code once, so that in runtime we have basically less to do. So if we want to render a button, we have a function element that basically will create the button, will append the price label, will append the price value, will append the space, obviously there is something like this, will append the $sign or will not do it, and finally will append the callback function to the DOM element. So all in all, instead of creating the virtual representation, Svelte is creating a lot of these compiled code, different code for different components, and thanks to this, a lot of calculations is basically moved from runtime to compile time. As a consequence, our build time will become longer, but our runtime might become shorter, so that basically there is less things to do. So this was the part about how does a framework know which part of the UI to update. And let's go to the part when does a framework know to update stuff. So let's take a look at this small snippet of code. We have 3 variables. Let's say that we are scheduling we're making an order in an e-commerce shop. We have a product with a price $4.99, and there is quantity 1, and the total price of the order is quantity multiplied by price. Now, if we increase the quantity, the total price doesn't get updated, obviously. But imagine today is year 2019, and entire technology is so advanced, and our variables are so primitive that there is basically no way for a variable to notify somebody, anybody, that its value has changed. We are using so low-level primitive elements, right? In our code, there is something in programming called invariance. It's a rule to be satisfied within our code. In this example, it's just that total price has to equal quantity multiplied by price. Obviously, I should rerun the total price formula, but should I do it always? Like, could the machine do it for me? Right? That's the thing. And in imperative programming, that's not easy. That's not necessarily possible in a neat way in order to do it just once. So a potential solution to this is what Michael has just was talking about, functional reactive programming used with RxJS. So now, you can think of RxJS introduces streams. You can think of a stream as a variable that will update other parties whenever its value changes. So instead of a quantity variable, we have a quantity stream, and there is some initial value like 1. We have price stream with initial value of $4.99, And we define that there is a total price stream that relies on both of them. And whenever any of the value changes, the value of total price will get updated. So this is the critical line. Now, note that in imperative programming, total price was a variable. It was just a value. But logically, it's not a value, it's a function, because it has dependencies. In our languages, we don't have a native way to define that a variable depends on another variables. This is a dependency, a very low-level one, but still a dependency. Now, RxJS solves lots of problems and introduces other problems as well. But there is a pretty steep learning curve. We have to learn the operators, we have to learn higher-order observables, we have to learn subjects, concurrency issues, and so on and so forth. Quite a lot of things to learn before. But what we get granted is when we increment the quantity, the total price will automatically get updated so that some of the responsibility is removed from us, which is very good. We don't need to think about it. Now, I would like to show you something that I find a lot simpler. And I like to think about it as imperative reactive approach. So in Svelte, if I want to have a state on my component, I just declare let var or const, but something that is new here is line number 4, is a reactive statement. So basically, if I have a variable total price and I want it to update automatically, I prepend it with $1. So whenever quantity or price changes, this line is going to be reevaluated. Especially when I click the button and quantity increments, I would like total price to automatically update. In other words, I don't have to put the line total price equals blah 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 just within the function of handle click. All this will be handled for me automatically. Of course, this is not JavaScript, and this is where Svelte compiling engine kicks in, so that Svelte needs to understand and reason about a lot of logic within the code, and it will produce disposable JavaScript, like you've seen with the incremental DOM. So it will figure out all the dependencies between the variables, and it will just push it into the compiled code that will be run in the browser, finally. I hope that you can see that it's just simpler. You don't need to think about any operators. Now, if I want to create a reactive variable, I'm not limited only to reactive variables. I can only do reactive side effects. So whenever my total price changes, I would like to update somebody, notify, or write something, read something, whatever. So if I define any kind of functions, whichever paradigm I use, async, await, whatever, I can just prepend a line of code, whether it's a single line, a block of code, if statement, while statement, for statement, I can prepend pretty much everything with $1. It's just $1, a colon, and you have reactivity built in. Now, I would like to relate to a quote of Edgar Dijkstra. Simplicity is a great virtue, but it requires hard work to achieve it, and education to appreciate it, and to make things worse, complexity sells better. This quote is pretty long. If we remove the needless parts and leave the important stuff, it goes like this. Simplicity is great. Now, the thing is, if we have reactivity or if we have DOM manipulations, there is a lot of complexity that needs to be somewhere. And the question is, if we design something, not necessarily a library, but also an application, how much of this complexity do we hide, and how much of the complexity do we expose to the user? Now, in RxJS, if you're using RxJS, you know that a stream will not produce any values unless you subscribe to it. If you subscribe to it, then you're responsible for unsubscribing. If you're subscribing multiple times, you also need to be aware of that, and maybe you would like to introduce a subject. There is a lot of responsibility on us. And now think about that. If we hide the complexity of the subscriptions, just like it's done in Svelte, there is no responsibility for subscribing or unsubscribing because it's done automatically for us. We have less power, but we have less responsibility. Simplicity reduces our responsibility. Now, let's take a look at what we've got available in RxJS. This is a dump of all the operators on the latest stable branch. These are 105 operators. Now, try to think, everybody, each of you who have used RxJS, how much time did you have to spend in order to go through, maybe not all of them, but just to get an idea of what's going on, what is the difference between switch map, flat map, all this kind of subjects, etc., and operators is only the first step, because then you have concurrency and you have all other concerns that you have to learn and you have to handle somehow. And now imagine all this is replaced with one operator, just the $, which will do the thing. Now, I would like to pick one more quote from Antoine de Saint-Exupéry. It seems that perfection is achieved not when there is nothing more to add, but when there is nothing more to remove. And in Sveld's model of reactivity, there is pretty much nothing we can remove because there is just $1. If we remove it, there is nothing left, right? Whether in RxJS there is already over 100 of operators, we could keep adding more, and in complex applications we do add more custom operators of our own. I'm not trying to say that Svelte is perfect, it has achieved perfection, not at all. It's actually far from perfect. One concern for me is that Svelte doesn't support TypeScript, which is a serious concern for me. But what Svelte has done with reactivity is the less is more rule. Basically, if we allow a user to use too many things, the user might get overwhelmed by all the options, and instead of choosing something, the user might just step back because it's just too complicated. If we reduce the possibilities, then the user might be more encouraged to do it. Yeah, having said that, and having used RxJS for almost 4 years commercially, basically, this is me. I'm looking at the $, operator. So, going back to Dijkstra's quote, simplicity requires education to appreciate it. Now, don't get me wrong, I'm not criticizing RxJS, not at all, actually, it's the opposite. I spent a lot of time learning it and working with it, and on the way, I learned a lot of different concepts that I didn't know they exist at all. I learned about hardware observables, about multicasting, unicasting, how to share subscriptions, what are the pros, what are the cons, and many problems, many other things that I don't have time to speak about. And through this journey, I learned how much responsibility is on me if I use that tool. Now, all this learning and all this education has allowed me to appreciate the simplicity of this $. Now, you could ask me, should I move from React or Angular to Svelte? My answer is no. You could ask me, so should I stick to Angular or React? My answer is also no. I'm not going to tell you what you should do. You know your program and you know your project best. It is you, the developer, to choose what is the future architecture of your JavaScript code. But keep one thing in mind, that the tools you choose and the frameworks you choose will enforce the mental model that you think in and that you work within. If you are an expert in one tool, but you don't know any other alternatives, then you are basically bound to only thinking within that tool. But if you try to leave your technical comfort zone and you try to think about different approaches, different ways you could solve a problem, then you have a variety of different ideas to solve the thing. Now, I would like to end with the final quote. Nothing is more dangerous than an idea when you have only one idea. I hope that will trigger some thoughts and will make you rethink the way you make decisions about your architecture. Thank you.